let's talk about this. We're going to talk about this briefly, okay? Because we are behind schedule, that's why. Now the S stands for
Substitution.
The N stands for
Nucleophile.
nucleophilic. And the 1 stands for
Unimolecular. Outstanding.
Nucleophilic, unimolecular, and this stands for substitution.
Nucleophilic, bimolecular.
If it is unimolecular, what
First
rate,
order.
What order should that be? First order. So the rate law. Rate law. Oh, you guys don't like rate law? But you don't like reactions either, so what do you like? You don't like reactions, you don't like rate law, you don't like analytic, you don't like
Biology.
biology don't have any of this stuff, right? The rate law for unimolecular is
First order.
first order. And first order has that rate law. And the rate law for bimolecular
Second order.
order is second order. Because we are talking about here nucleophilic substitution. The order for this depends on the alkyl halide. And here, the rate for this one depends on both the alkyl halide, yes, the concentration of the alkyl halide, and the concentration of the nucleophile. How did we find the orders on this thing?
Experimentation only.
Experimentally. We double this concentration, and if the rate doubles, that was first order.
First order.
We double this concentration, what happens to the rate? Doubles.
Doubles.
We double this concentration, what
Dou-
happens to the rate?
Doubles.
But if I double the concentration of the nucleophile here, what happens to the rate?
Nothing.
Stays the same. Nothing happens. Stays the same. So, increasing the amount of nucleophile you have for this reaction, will it give you a faster reaction?
No.
No. Okay. Now let's talk about this mechanisms occurs in. So let's say this reaction occurs, and this is weird, okay? This reaction occurs in 2 steps. It is unimolecular, but it occurs in 2 steps. And this reaction occurs in
One
1 step.
one concerted step, right?
Yes, 1 concerted step. You've been reading the book, huh?
I have been. David Klein all the way. I mean Calvin Klein, I'm sorry.
They actually teach you that before they do the additions.
Yeah,
They
they
teach you that.
that's in
the
chapter
elimination.
5.
That's- Yeah,
Yeah.
They teach you that before addition and elimination.
yes.
Yeah.
No, they teach you they teach you that and elimination before they teach you the addition of
Oh,
alkenes.
who's they? So, all right. Let's talk about this mechanism is, should I say?
Stepwise, right?
Okay, let's do the mechanism, okay? Let's not continue summarizing stuff.
I'm in NASCAR.
Mechanism for Sn1.
Just kidding.
You are going to have this thing here, and
Yeah.
you are going to have, we did talk about nucleophiles and electrophiles before, yes?
Of course.
An electrophile, it's either positive or it could be neutral. And a nucleophile could be either negative or Neutral. Either way, it has to have electron pairs, yes?
Correct.
If it is neutral. And the nucleophile does what?
Attack
nucleophile
the
attacks
electrophile.
the electrophile. Now, we have the alkyl halide, in this case is what? What is the alkyl halide here? The nucleophile or the electrophile?
Electrophile.
Electrophile. And which one is the nucleophile? The nucleophile. Okay, many nucleophiles. We're just gonna talk about this later, okay? So what happens is when you have an Sn1, there is a formation of a carbocation.
Go through rearrangements, right?
This, yes, with the possibility of rearrangement. Every time you have the formation of a carbocation, there is a possibility of rearrangement, and it will rearrange. So, the formation of the carbocation, how does that happen? The chlorine says, hey, I'm out,
Leaving group.
okay?
Yeah.
The chlorine is the leaving group.
It's a good leaving group too.
It's a strong.
Yeah, because OH is not.
Yeah, it wouldn't suck.
It is a good leaving group because it is stable, it's nice and fluffy. So, what happens is you form this. What did you form?
You need a plus?
What did you form? When the chlorine took the electrons, it formed this
Carbon
carbocation.
Yeah.
And the carbocation
Is sp2.
looks like that.
Yeah.
It is trigonal planar.
Uh-huh.
Let's put this positive inside. Because it is trigonal planar. What happens if it is trigonal planar? It gets attacked
Yeah.
by the nucleophile
Mm-hmm.
from either this side
Oh, the other side.
or this side. Okay? Most of the time I like to draw this flat. So I can say attack from the top and attack from the bottom. Okay? That's how I like it. But here is attack from the left, attack from the side. So if it attacks from one side or from the other, what you are going to get is, what are you going to get? A racemic mixture. If it is chiral. Is this racemic? Can this ever be racemic here? No. This is not racemic. But you are going to have the nucleophile. And the nucleophile could be neutral or it could be
Partially
negatively
negative.
charged.
Okay.
Now the leaving group left and it's somewhere, okay? It will be Cl minus somewhere. And it depends on the rest of the stuff, that's what it will be attached to, okay? So this happens through the formation of a carbocation and it produces a racemic mixture. So this reaction occurs in two steps. What does it give you? Racemic
Racemic
mixture.
mixture. Professor.
Yes.
I read that like, so you got the like the leaving group is on this side, so it'll attack from the back because that leaving group have lone pairs with a large area of electron density, forcing it to attack from the opposite side.
No, that's for Sn2. It is true, when this is leaving, it doesn't completely leave.
Okay.
So, but I don't really want to talk about that.
Okay. Okay. All right.
So let's do Sn2, okay? And then we'll go home when we do 5 to 10 problems. You guys don't have anything better to do in your house anyway, is that right? I don't
Did
think
he
any
play
of
tonight?
Game of Thrones.
When did this thing come out yet?
April. I
Oh,
can't
Game
wait.
Here's
of Thrones.
Sn2.
I can't wait for that.
I can't wait.
Can't wait for what?
Game of Thrones.
What's that?
Game of Thrones is
Game
a
of
show.
Thrones. Yeah, that's
Yep.
yeah.
Okay? Now let's not.
Keep it.
What's happening?
Professor, you're tired.
That's enough mine.
You got upset because I wrote and I. I'm telling you, girls are priceless. So, would that like to form here a carbocation?
No.
This is not going to form a
No.
carbocation, yes?
No.
This did not form a carbocation because it is not tertiary.
Tertiary.
In Sn1, the more stable one is tertiary.
Tertiary. It's the opposite. Sn2.
Because it forms a tertiary carbocation. The faster reactions over there are for tertiary. These are, well, this one in specific, it's methyl. But primary works very fast too. And what needs to happen here is the nucleophile is going to do a backside attack.
There you go, yeah. Okay.
Nucleophile, backside attack. Sn1, it attacked from the top and it attacked on the bottom. That guy is a man, both sides. But this one only likes the backside. There's no play. So he goes, oh, here's the back. Go in there, slam that. And what happens is, there goes the leaving group.
Oh my
Okay?
God.
Something bad gotta happen. So, I said attacks from the backside.
It flips it, right?
Yes, it kind of flips it. Now this carbon used to be in the front here, now the nucleophile will be in the back. And this kind of makes this stuff turn inside out. So what does that give you? It gives you inversion of configuration. Remember, this is like the mirror image. Do you see it here? This is like the mirror image. What the difference is that this bromine here got replaced by a nucleophile. But it happened through the back. If it has the same priority, right?
Yeah.
If it has the same priority, it will be the reverse of what this is. So if this is R and the priority stayed the same, this will be S. And that's called inversion of configuration. Now, how many steps was this?
One.
One step. The attack was made, and this bond was breaking as this one was forming. And I'm going to show you how that looks. That looks like this.
Yeah, with the dash.
Here's the H.
With the dash on it.
And now, the dash is like this. This is like that. The bromine is here. Let's not write it like this. Let's say the bromine
Yeah, there you go.
is leaving
Uh-huh.
while
This is forming.
the nucleophile is forming a new bond. This is a pentavalent transition state.
Do you have to put like the brackets with the thing,
You could, yeah, like this.
with the telephone sign?
Yeah, no. Transition state. That telephone sign, I did it in 1046.
I'm sorry, you said it was a penta what?
Pentavalent.
Okay.
Pentavalent means 5 bonds to a carbon, right? You get 5 bonds to a carbon, you win the Nobel Prize in chemistry, like George Ola. All right. So that was one step, yes?
Yeah.
Inversion of configuration. Which one is the fastest?
Sn2.
Yeah, no, Sn2, but which one?
Oh,
Which
primary.
alkyl halide?
Primary.
So
Yeah.
alkyl halide are the primary. Primary alkyl halides were the fastest, and what this happens with? Inversion of configuration. So primary is faster than secondary, which is faster than
tertiary.
tertiary.
That pretty much
Tertiary.
doesn't exist, right?
Yeah, tertiary almost never happens
Yeah.
via this, because if you have tertiary, what it likes to do is Sn1.
Sn1.
But, so this is faster than
Just the
secondary,
opposite.
which is faster than primary. Which primary never does
Happens.
Sn1.
Sn1.
So whenever I show you on the test primary, what is it going to do no matter what?
SN2.
SN2. Whenever I show you tertiary on the test, what is it going to do?
SN1.
SN1.
But secondary could do both, right?
And secondary now can do both. So there are other conditions we can use to make either one or the other. For SN1, I'm going to tell you that the best solvents of a specific type are a big deal. And these solvents of this specific type are called polar protic.
Polar protic, yeah, damn. And that's apolar protic, polar aprotic.
And polar protic means what? Polar means polar, and protic means
Non-polar protons, yeah.
So polar protics are like what then?
HF,
Alcohols?
HF,
Does that make sense? This is an alcohol.
Yeah.
I don't know.
HF,
This is
HF,
that? I don't know. Water,
yeah.
alcohol. How do you spell alcohol? Alcohol. And carboxylic acids. The fastest reactions are in water and alcohol, and carboxylic acids after that, okay? But water and alcohol are the fastest. The solvents here that will favor this are called polar aprotic. And aprotic means what?
Non-polar.
It does not have a proton. And polar aprotic are like DMF and DMSO, probably HMPA. This here is called DMF, this is called dimethyl formamide. Okay, this is from formaldehyde, yes?
Yeah.
And DMSO is like this. Dimethyl sulfoxide. These are polar, yes? Are they polar? They are polar. And they do not have a proton to give. Okay? What are they very good at? They're very good at stabilizing positive charges, and not very good at stabilizing negative charges. The reason why they're not good at stabilizing negative charges is because here is the center that is positive, yes? Here and here. But this center is hindered, or this center has things around it, so the negative charge can't really get in there. So it's the same for this. But positives are with these electrons up here. Okay? Yes or no? Did you write polar aprotic?
Yeah.
Good at stabilizing positive charges, not so good negative charges. What are polar protic good at stabilizing?
No.
They can... What type of forces would there be present if you had a positive charge or a negative charge in any of these?
Ion.
Here? Ion?
Ion.
Dipole forces,
Dipole,
yes?
yeah.
Ion dipole forces. Because that would produce a carbocation. The carbocation would be stabilized by those polar protic. Okay guys, you want to call that a day?
Yes.
Sophia and Maria, I want to talk to you too.